Hello students, welcome to series of lectures on digital speech processing. So in this video you will be able to learn the topic called filtering and adaptive noise cancellation. So in the previous video we have already seen the speech enhancement technique, that is spectral subtraction. Now this is the another two methods we'll be having as a speech enhancement process, that is filtering technique and then adaptive noise cancellation. So let's get started. So this is the lecture learning outcome of this video. On completion of this lecture, you'll be able to analyze the adaptive noise cancellation method. Alright, so this is a block diagram of speech enhancement that we already know. The desired speaker and other speakers are also going to be interfering with the desired signal, and the background noise is also going to be there. So there is a sum up of all the signals at the output of the adder, and that will be processed and that can be transmitted to the communication channel, and through which the transmission noise is also going to be incorporated. Okay, so at the output of the communication channel we are expecting that is a pure noisy signal, and from that noisy signal we need to enhance the quality of the speech signal, that is the desired one. Okay, so for that we are going to be looking for the block that is enhancement process. So during this enhancement process we are going to be using several kind of the methods or the techniques that can be possible to enhance the quality of the speech. And I keep on telling the same thing, that so when we want to enhance the speech signal, it is not only the quality of the signal, but also it has to be understand each and every word which are spoken by the speaker. Okay, that we are calling as the term as intelligibility. Okay, so we need to enhance the intelligibility of the signal. Okay, so in that way you need to understand, and at the output of the enhancement process you will be having the listener. Okay, so the listener will get the enhanced speech signal. Okay, so that is the ultimate goal of our speech enhancement process. So this is a block diagram of the speech enhancement. Now coming to filtering and adaptive noise cancellation. So these are the two important methods for enhancing the speech quality, the way how we have already seen for the spectral subtraction method. So when we for example, when you look back to the spectral subtraction method, so we are going to be subtracting the spectrums, okay, of the noisy spectrum, the estimation of the noisy spectrum from the noisy speech, okay, in the spectral domain. Okay, so now let us see the filtering and then adaptive noise cancellation. So filtering and adaptive noise cancellation is two common speech enhancement techniques which are used to remove the noise from the speech signal. That is the ultimate goal of us. And both techniques work by filtering the speech signal to reduce or eliminate the noise component, but they differ in how they estimate and adapt to changes in the noise environment. This is also a very interesting point that we need to note. Okay, so these two techniques work by the filtering the speech signal to reduce or eliminate the noise component. That means, so what we are doing, for example, imagine a situation where the person is recording a speech sentence. Okay, then that has to be filtered before that can be processed to the further blocks. First we need to filter, okay, the speech signal in order to reduce or eliminate the noise component, if at all that is having in it. But the differing how they estimate and adapt to changes in the noise environment is the biggest challenging task for us. Now filtering involves using a filter. As you know, here the digital signal processing filter or a hardware filter you can use to remove the noise component from the speech signal. Okay, now how we should design, this is also very important thing that we need to focus, because in order to remove the components, okay, the noise components particularly speaking, from the desired speech or the noisy speech, so we are going to be using the filtering, there is no doubt about it. But in what way we are going to be using that filter, how to design that filter is also very important for us. So the filter is designed based on the properties of the noise and the desired frequency response of the speech signal. This is the first and foremost thing that we are going to be looking in order to design any kind of the DSP filter or hardware filter. Okay, so we need to design a filter in such a way that it has to based on the properties of the noise. Okay, so normally what we do, we are going to be using the additive white Gaussian noise. Okay, so those properties are already known to us. So based on those properties, we are going to be designing a filter in such a way that it has to suit the components of that. Okay, and the desired frequency response of the speech signal. So that is a very important point. And the second point is that filtering can be effective for removing stationary noise components, but it may not be as effective for non-stationary or the time varying noise. Here one point I would like to mention to you students. See, you have already designed based on the properties of the noise components, and then filtering that can be effective for removing stationary noise. Okay, we also clearly disseminated the things, what are the noise component, what are the noises, various noises which comes under the stationary, and what are the various noises which comes under the non-stationary. Okay, so when you see the ceiling fan, okay, the sound that is coming from the ceiling fan is stationary. Okay, it is not a time varying noise. Okay, so that is a stationary noise. But the filter, whatever that you have already designed, it is best suitable for removing the stationary noise, but it may not affect you that much, okay, for the non-stationary, because the speech is a non-stationary. But even though when you record any kind of the speech, then what we are going to be doing, the initially we are dividing that into the frames, okay, with the duration of 10 to 20 milliseconds. The reason is that because we need to apply that into the frequency domain, right, in order to get the frequency response of the spectrum. First we need to apply to the DFT or FFT. Okay, so this DFT or FFT well suitable for the stationary. That is the reason actually before we process further. So instead of taking the direct entire duration of the recorded speech, we are dividing that into frames in the order of 10 to 20 milliseconds, because during that portion we are considering that as a stationary signal, so that comfortably we can apply discrete Fourier transform method or the fast Fourier transform method. Okay, alright. Now, adaptive noise cancellation. So on the other hand, which involves estimating the noise components in the real time and using this estimate to cancel the noise from the speech signal. Okay, that is the motto. And now ANC algorithms which uses the reference signal, which is a noise signal, and that is correlated with the noise in the speech signal, and an adaptive filter to estimate the noise component of the speech signal. This is one kind of way how we are going to be eliminating the noise components of the speech. Okay, so what we are doing here in the adaptive noise cancellation, nothing but we are going to be developing an algorithm and we are using the adaptive filter. Okay, adaptive filter we need to use, and normally what it does is that it uses a reference signal and which is a noise signal, and intentionally we are creating a noise signal that we are correlating with the noise in the speech signal. Okay, now the second point, the adaptive filter is updated continuously based on the difference between the noise speech signal and the reference noise signal, and this estimate is used to cancel the noise from the speech signal. So that is a procedure actually we are going to be adopting in the adaptive noise cancellation. Okay, so in the adaptive filter, because why we are using the adaptive filter? Adaptive filter is updated continuously based on the difference between the noisy speech and the reference noise signal, so as to remove the noise from the speech. Alright, so this is the block diagram of the adaptive noise cancellation. Okay, I clearly mentioned in the previous slide, we are using the reference signal, that is a noise signal that can be given to the sample delay. Some sample delays units we are going to be taken into consideration. Okay, and this is a primary signal P of n. You can see here, this is a primary signal P of n, and this is the reference signal wantedly we are going to be giving as a noise signal that has to be correlated with the noise in the speech. Okay, right. So this is the primary signal, and so these are the weight vectors. Okay, so when you take the delay, and that can be multiplied with the weight vectors, and that can be given to the adder here, and similarly when you take the second weight vector, that can be given to the adder, like that. So Wn weight vectors are going to be using. Okay, now here what is coming here, so this is all the weight vectors are going to be adding here, and we'll be getting some different signal. Okay, this is one input to the subtractor and other input is a P of n. So what we need to do is that the D of n is nothing but the difference between the primary signal and the reference signal that is coming from the weight vectors. Okay, so this difference signal is given to the LMS adaptation. Okay, so what is our goal here? So that difference should be equated to 0. Okay, so in such a way that this LMS filter, the least mean square adaptive filter we are using here in order to update the coefficients, okay, based on the properties of the filter and all. So we are going to be updating the coefficients of the filter in such a way that it has to give the output signal V of n, and make sure that this V of n signal should be the enhanced speed signal. So that is the process actually we are going to be doing in this analysis, that is adaptive noise cancellation. Thank you students. Thank you for watching this video.